Okay. For section 10, deals with mathematical modeling and variation. Now, when they talk about mathematical models, okay, they're talking about something representing real-world data. Okay. Now, the mathematical model part of it, though, you can do it graphically, but the main thing they're looking for here is an equation version or a function version. Okay? So something you can modify to different situations. So, if I have a mathematical model, well, and we're doing real-world situations out of the book, what does that mean? Everybody's favorite type of problems. Story problems, word problems. So this section deals with story and word problems. So, now, one of the main ways we're going to deal with this is using least square regression. So you're going to need your graphing calculator for this, so go ahead and take that out. Okay? The idea is we're going to have different types of mathematical models that approximate real life. In order to find a model that approximates the data most accurately, the way statisticians do it is they use a measure called the sum of the square differences. The idea is you look at your model, your equation, and how far off every data point is from that. Okay? Square those values, add them together, that gives you a reference for what's going on. Okay? Now, one of the main ways we're going to do this on the calculator is when you have a set of data, we're going to use that line of best fit. We're going to do a regression line. Everybody remember how to do regression lines in their calculator? We'll look at it, but people should be comfortable with it. Now, you can also do it visually by rough graphing, but we're going to try to get a little more accurate than that. Okay. So, if I have this example, the average price in dollars of prescription drugs in the U.S. from 2000 to 2007 are shown on the table next up. Linear model is given there. Y represents the average price in dollars, and T equals 0 is the year 2000. I'm going to plot both the data and this model. When they talk about model, they're talking about an equation on the same graph. Okay, so if I look at this data set, now I want to put both of these on the same graph. Well, first off, how do I actually plot these points on the graph? Go to stat plot, make sure you have, oops, there we go. Stat plots, I want to make sure that's on. I also want to make sure it's referencing L1 and L2. If it's referencing something else, it won't actually graph. So then I need to put in the data. Where at? Yeah, stat. I'm going to go to edit. Okay, that gives me L1 and L2. I'm going to put these in. Now the years are 0 through 7. I have different data in here right now. So 45.79, so on and so forth. Okay. So now, if I want to plot these two things, well, we turned on stat plots to be able to get the points. What else do I need to do? Do what?
Equation that was with it.
Yeah, type in the equation to y1. So once you have the data in there, under y1, put your equation. Wait, why don't I have anything showing up? Because it's what?
Your window.
The window doesn't match. Because I need the data that's in there. What's a good zoom that I could do to jump straight to the data? Stat. Go down to zoom stat. The nice thing about that, it'll always make sure all your points are visible. So if I go down to zoom statistics, the 9th one, it'll actually give me the data and the line, and you can see it all. Might not be the best window either, because honestly, well, actually that's not bad. Forget it. The Y max, you could change it so it actually starts at 0. So it gives you a little bit better idea of what it is compared to 0, but otherwise it was still good. Yes?
Mine says error when I press through the stat.
Okay, let me go around and take a look at them. Okay, so everybody has this graph, or at least some version of it. Let's do another one of those, but instead of them giving you the equation, we're going to figure out the equation. Okay? So for this one, the number of women in millions in the civilian labor force in the U.S. for those same years are given. Find the least square regression line that fits these data. Okay? Now the way this is behaving, it is behaving linearly. So we're going to do a linear regression. So we need to change up the data and put these new ones in. So go back to your stat and re-edit. Well, the nice thing is you only have to do one column. Now, we'll finish typing the points. How do I actually get the linear regression line? Stat, calc, and then linreg. Now, on newer calculators, the nice thing is, because I need to graph both these as well, I can store it directly here. So if I go down to store regression equation, I just need to put it in Y1. Now Y1 is under the variables button. The variables button is right next to program, vars. Hit vars, go over to Y variables, regular function, and Y1. Okay, that'll store it. There are other ways to do this. Honestly, there's about 4 ways to do it on the calculator. Okay, so up here I'm going to go to vars is the button right next to program. Hit that. And then you have general variables, Y variables, and the color thing. Go to Y variables. And then function is the normal Y equals mx plus b. So then you just select which one you want it to. It'll put that in there. It'll erase whatever's there and put it in there. That's the way I do it, just because it's on the same screen. You don't have to mess with a lot of stuff. So when I calculate, it's going to give me those values. Now, did anybody not get the R values? Okay, and what are the R values? Correlation coefficient. It tells you how closely the data matches up, right? So for that correlation coefficient, if you don't have them on, you need to turn diagnostics on. Older calculators, you got to go into the menu system a little bit. Newer ones, if you hit mode, down here towards the bottom where it says stat diagnostic, you can just turn those on. Yes?
What would MSE be, do you know? Capital M, capital S, lowercase e.
Not a clue. Sorry. Curse of the Casio. Yeah. Yeah.
It's not drafting the line.
Now, did you do zoom stat again?
It's already. It's just not drafting the line.
Today's month? Oh, God. No, it's 4. Yeah, it's 12 or 4.
You're doing L2 and X.
Oh, that's backwards.
Change that to L1, L2. Okay. So when you do that, that should bring it up to that main screen. If you have an older calculator, or can everybody do it that way, or does anybody need a different method? Okay, good. Graph it. Now, because I didn't change my window, it looks a little strange. You can do zoom and that, and it will fix it. Or at least make it look more like a diagonal line. Okay. Questions on that? Okay. Now, the other thing we're going to talk about besides the modeling is we're going to talk about the variation. Okay? Now, there's different types of variation in general. Firstly, we're going to deal with direct variation. Now, for direct variation, the idea is the relationship between y and x. As one changes, the other changes by the same factor. Okay? So if y varies directly as x, or you'll sometimes see y is directly proportional to x. These all translate to y equals kx. K is some constant that's a multiplier that you're going to use, but otherwise it's always going to be that constant relationship. So just K is for constant. So if I have a problem that gives me that they're directly proportional, this one says simple interest on an investment is directly proportional. So that tells me I'm going to use this, y equals kx. It's directly proportional to the amount of the investment. By investing $2,500 in a certain bond issue, you obtain an interest payment of $187.50 at the end of 1 year. Find a model that gives the interest I for this bond issue at the end of 1 year in terms of the amount invested P. So they're giving you the two variables you're going to use in place of x and y. Okay? So the idea is you can write a really general form of this thing where you don't know what k is yet. That's what you usually want to start with. So now looking at this, if I'm writing I in terms of P, well, what's the equation going to look like when I replace the variables up here?
P equals IX.
Okay. X and Y are your variables. K, remember, is a constant. So these are variables. So these are what are going to be replaced, the X and the Y. Now it says I in terms of P. Okay? So what that means is the P is going to be the X. It's the independent variable. I is based on what a P is, the way this is written. I is going to equal some number times P. Okay? Now the thing is I need the K value. How could I go about finding the K value?
Like the 2,500 in for P.
Yep, plug in the 2,500 for P.
187.5 cents.
Yeah, 187.5 for the interest. Does everybody see why those are going where they're going? What's going on here? Okay. Then just solve it. What's K going to be? .340 is probably right. What's the decimal form?
0.075.
0.075. Since we're talking about interest, I'd rather keep the 0.075 because what percent is that? 7.5%. So I'd rather have a decimal in that case. Technically, the other's still fine. So the idea then, my formula is going to replace the K with that value. So this is the mathematical model for this situation, is I equals 0.075P. That's what they're asking for when they ask for a mathematical model. Questions? Now that's direct variation. Direct variation is the most common. Now they do have some little modifications on it though, when you don't have the exact same multiplier going from step to step. Because sometimes you have a power thrown into the mix. So if it says something along the lines of y varies directly as the nth power of x, okay, that means it's y equals k times x to the n power. Okay, so if I look at that situation down here, neglecting air resistance, the distance s that an object falls varies directly, so it gives you that it varies directly as the square of the duration t. So they're literally telling you s varies directly as the square of t. So what's the general form of that equation going to look like?
S equals KT squared.
Yeah. S equals kt squared. Again, if I want an equation, I need to find what?
K.
Okay, so plug in your numbers. S is the distance, is equal to k times the time squared. So 144 divided by what?
9.
Gives you 16. So then my formula looks like what? S equals 16, t squared. Which should look familiar to anybody that's gone through physics. But they'd probably prefer it to be 4.9. So,
I don't take physics yet.
okay. It's referring to this acceleration due to gravity is 32 feet per second per second. So a falling object, you have that to 16.
Mind blown.
Okay. You'll get there.
I'm taking
Assuming you take physics.
I'm taking 18 next year.
Okay. How far will an object fall in 6 seconds?
Very far.
What do you do? Yep, plug in 6 seconds. So the distance is equal to 16 times 36,
Whoa.
which
Lot of
is
feet. 576 feet.
576 feet.
No, I did it in my
Questions? Okay. Direct variation is one type. Another one that shows up is inverse variation. Now for inverse variation, well, it basically just means they're in an opposite relationship to each other. Y varies inversely as x means y equals k over x. Now you will sometimes have combined variations where it mixes the direct and the inverse. Okay? This one though just sticks to the inverse for now. Company has found that the demand for its product varies inversely as the price of the product. So if the price is $275, the demand is $600. So write an equation relating demand D and price P. So if it's an inverse relation, what's that going to look like? Y equals k over x, but in this case, would look like what?
Would be D equals K over P.
Yeah, D equals k over P. So, go ahead and find k. So plug in 600 units, k over 275. Gives you what for a k value?
1,650.
1,650. So the right in the equation part is just D equals that 1650 over P. So the demand when the price is 325. What do you get for the demand?
507.69.
Yep, just plug in the price. So considering this, what's the label on this?
Or units.
Units. I'm probably not going to have a fraction, so I'd round it to 108 or 508. Because whatever you're selling, you probably aren't going to want to sell. What was it? 7/10 of one.
Yeah, sometimes 0.69.
All right. Now you can also have those multiples happening at once. You can have what's called a joint variation. Joint variation refers to if you have z varies jointly as x and y. So it's going to have more than just two variables going on. Okay. So let's look at the worst case scenario of this kind of problem.
They only give us
The max load, they give you no numbers. The max load that can be safely supported by a horizontal beam is jointly proportional to the width of the beam and the square of its depth, and inversely proportional to the length of that beam. Determine the change in the maximum safe load under the following conditions. So I want to create an equation so I can see what's going on with this. Okay, it's going to keep the k in it, but how many variables are actually going on here?
4.
4. Because you do have width, depth, and length, but you also have what it equals, the max load. Okay? So I'm going to have the max load is equal to, well, it says jointly proportional to the width and the depth, but inversely proportional to the length.
Okay, so W times D over L.
W times D over L. Anything I'm missing there?
Probably because
Squared and the K. Where's the squared at?
outside
On what?
fraction.
The whole thing?
Maybe, probably not.
W and
Why is it D? Yeah, it's the square of its depth. So the D is the only thing actually squared. The width of the beam is just a direct variation. The length of the beam is that inverse variation. The depth of it gets squared. And then the K value, you can put it out front, but honestly I just usually put it in the numerator. So, looking at this formula, is everybody good on how we got to the formula? Kind of, that's all right. You can practice this weekend. You got a nice 3 days to do it. For this,
you're funny.
I got it.
if I double the width, what will it do to the max load capacity? It would double it. In order to maintain balance on the equation, if you double the W value, the max load value also has to double. So it doubles the max load. Okay, what about if I double the depth?
2d squared.
Quadruples it, yep. So the idea there is because it's squaring that depth value, you'd square the doubling as well, giving you quadrupling the max load.
So that's where you place 3 variables in there. Max load.
That's the easiest way to do it, yep. Now, what about the length? What if I doubled the length? What would it do to the max load? It'd cut it in half. Okay. Yeah, ideally, if you can avoid it. So, any questions on any of it?
Do you have another one of those? Everything together,
Not prepared, but there's some in the homework you can practice.
Wait.
All right. Test is next Wednesday.